Example 5.2. Solve the following system of 4 equations with 4 unknowns: x plus y plus z plus w equal to 0, x plus y plus 3z minus w equal to 4, 2x plus y minus z plus w equal to minus 4, minus x plus y plus z minus w equal to 2 by Gaussian elimination. First, we write down the augmented matrix, which is a 4 by 5 matrix now. The first row is 1x, 1y, 1z, 1w equals 0. Second row is 1x, 1y, 3z minus 1 times w equal to 4. Third row is 2x, 1y minus 1 times z plus 1 times w equal to negative 4. And the fourth row is minus 1 times x, 1 times y plus 1 times z plus minus 1 times w equal to 2. We notice that the first non-zero entries is in the first row, first column. Since this entry is already a 1, it is a leading one. And we must create 0 for entries below leading 1. To create a 0 at second row, first column, we can take the first row times negative 1, add it to the second row. Then the new second row becomes 0, 0, 2, negative 2, 4. To create a 0 in the third row, first column, we can take the first row times negative 2, add it to the third row. And then the third row becomes 0, negative 1, negative 3, negative 1, negative 4. To create a 0 in the fourth row, first column, we can take the first row times 1, add it to the fourth row. Then the new fourth row becomes 0, 2, 2, 0, 2. Next, we will try to work on the second row to create a leading one in the second row, second column. We can do this by interchanging the second row and third row. After interchanging the second row and third row, the new second row becomes 0, negative 1, negative 3, negative 1, negative 4. And the new third row becomes 0, 0, 2, negative 2, 4. Now we have a non-zero entry in the second row, second column. We need to create a leading one at this location. You can use negative 1 times row 2. After we multiply each entry in row 2 by negative 1, the new second row becomes 0, 1, 3, 1, 4. Now that we have a leading one in the second row, we must create 0 below and above this leading one. In order to create a 0 in the fourth row, second column, you can take minus 2 times row 2, add it to the fourth row, and the new fourth row becomes 0, 0, 3 times minus 2 is minus 6, plus 2 is minus 4, 1 times minus 2 plus 0 is minus 2. 4 times minus 2 is minus 8 plus 2, I get minus 6. In order to get a 0, in the first row, second column, I can take second row times minus 1, add it to the first row. Then the first row becomes 1, 0, minus 3 plus 1 is minus 2, minus 1 plus 1 is 0, minus 4 plus 0 is minus 4. Next, we will work on the third row. Now the first non-zero entry is a 2. We need to create a leading one here. We can use a third row times half. So, after multiply the third row by half, the new third row becomes 0, 0, 1, negative 1, 2. Now that we have a leading one in row 3, we must create 0 for entries above and below leading one. In order to create a 0 in the first row, third column, we can take 2 times row 3, add it to the first row. And then the first row becomes 1, 0, 0, minus 2 plus 0 is minus 2, 4 plus minus 4 is 0. In order to create a 0 in the second row, third column, I can take third row times minus 3, add it to second row. Then the second row becomes 0, 1, 0, 3 plus 1 is 4, minus 6 plus 4 is minus 2. In order to create a 0 in the fourth row, third column, I can take 4 times row 3, add to row 4. Then the new fourth row becomes 0, 0, 0, minus 4 plus minus 2 is minus 6. 2 times 4 is 8. 8 minus 6 is 2. Now we move on to the fourth row. The first non-zero entry in the fourth row is negative 6. We will create a leading one at this location. You can achieve this by multiplying the fourth row negative 1 over 6. After we multiply the fourth row by negative 1 over 6, the new fourth row becomes 0, 0, 0, 1, minus 1/3. Now that we have a leading one in the fourth row, we must create 0 for all the entries above this leading one. Let's create a 0 in the third row, fourth column. You can do this by using fourth row added to the third row. And then the new third row becomes 0, 0, 1, 0, 5 over 3. Then we will create a 0 in the second row, fourth column. You can do this by using fourth row times minus 4 added to the second row. And then the new second row becomes 0, 1, 0, 0, minus 2 plus 4 over 3 is minus 2/3. We move on to create 0 in the first row, fourth column. You can do this by using fourth row times 2 added to the first row. And then the new first row becomes 1, 0, 0, 0, minus 2/3. This final row reduced epsilon form tells us a solution. The first row tells us x equal to minus 2/3. The second row tells us y equal to minus 2/3. The third row tells us z equal to 5/3. The fourth row tells us w equal to minus 1/3. Not many low-end scientific calculators can solve a system of 4 equations with 4 unknowns. However, this Canon calculator F789SGA can solve. First, I set the mode to equation 5. Then I select 4 equations with 4 unknowns, which is 3 here. Then you enter the coefficient, which is 1, 1, 1, 1, 0 for the first equation, and the second equation is 1, 1, 3, minus 1, 4. Third equation is 2, 1, minus 1, 1, minus 4. And the fourth equation is minus 1, 1, 1, minus 1, 2. And then you press equal. The first unknown is minus 2/3. The second unknown is minus 2/3. The third unknown is 5/3. The fourth unknown is minus 1/3. Now don't get confused, because in the calculator the first unknown is w, because the equation is go by w, x, y, z. Thanks for watching.